Okay, in my previous video on inputting and describing data for a single numeric variable within R, we took a set of quiz scores and we created a numeric vector of scores. So the vector was called quiz score, and that was our data object, and we input the data, or we created the object by inputting it using the C function. Next, we followed up by looking at utilizing various functions in order to obtain various descriptive statistics, including a histogram and a kernel density plot. We then followed up by utilizing the psych package and the paste CS package right here in order to obtain various descriptive statistics. Keep in mind that packages basically are a collection of functions, and it prevents us from having to go through sort of in a piecemeal way in order to obtain our descriptive statistics. We can basically utilize a package which contains a number of functions in order to obtain much of the same information and other information as well. So just keep in mind that within R, a package is nothing more than a collection of functions, and it allows you to obtain a variety of different types of outputs depending on whatever analyses that you want to carry out. So what we're going to do for this particular demonstration is we are going to utilize the summarytools package, which is another way of obtaining some descriptive statistics. And then I'm also going to follow up with just a couple of other functions that are available to you when looking at the distributional characteristics for your numeric variable. So I'm going to copy this off, and I'm just going to paste this into R rather than typing it up. So there it is, and I'm going to hit enter. And so you can just see again, we typed in quiz score, that's the name of our vector. We use the C function right here to essentially input the values on our variable. If I want to take a look at the vector again, I can just type in quiz score. There are the numbers that are included in the vector. If I want to look at the structure, I can just use the str function quiz score in order to look at the structure, and you can see it's a numeric vector of values. So what we want to do now is kind of bypass some of this other stuff and just go straight to the summarytools, utilize the summarytools package. So I'm going to type in install period packages, and inside quotation marks utilize summarytools, and then hit enter. So basically if it's the case that you've already installed this package, then there's no need to keep reinstalling it. But if this is the first time, which for many of you it may be, then you would need to type in install packages and then go to the mirror site that's called up. There are a number of different mirror sites. Just generally you want to pick the one that's closest to you or pretty close to you. So I'm going to pick the one for Texas right here and click on OK. And so now it's installing the package. So moving forward, if I ever want to use this package again for other analyses, I don't need to reinstall it. But if I want to use the package, I am going to need to use the library function to call it up. So I'm going to type in library summarytools and hit enter. And so now you can see we just get a little message just saying that summarytools was built under this version of R. Now, in order to look at various descriptives, first off, I'm going to use the descr function, basically describe, and then type in the name of my vector. So I'm going to type in quiz score and hit enter. And so now you can see we have the mean, standard deviation, minimum, maximum values, the quartiles, skewness, kurtosis, and so forth. You'll notice it says number valid is 12. Basically, there's no missing data in the data set, and percentage of valid is 100. So 100% of the cases are valid in this data set. So just keep in mind that this function right here is associated with the summarytools package. So if you chose to just type this in and you had not called up this package, then you would end up with an error message. So just keep that in mind. Okay, so now what we're going to do is we'll use the df summary function So we're going to type in df and then capital S summary and then quiz score and then hit enter. And so now you can see that we get some of the same information we've gotten before. There's the mean, standard deviation right here, minimum, maximum, median, interquartile range, and so forth. You get a little plot of the data as well. Number valid is 12. 100% of the cases are present, 0 missing, 0% are missing. So if we want to look at obtaining frequencies for the scores themselves, we can use the FREQ function, or for frequency. So we'll type in FREQ and then quiz score and hit enter, and there you go. So you'll notice over here we have the individual values that appear in the data set and their respective frequencies right here. You'll notice that down here you've got a little NA in brackets are kind of highlighted right here, and it says 0. So 0 cases, basically the NA is denoting missing values. And so no cases in the data set had a missing value on this particular variable. So you'll notice that the percentage valid and the cumulative percentage valid, these are, this is reflecting the percentage of cases at each value on our variable. And it's not taking into account, any missing cases. The cumulative percentage is the same as well. It's basically utilizing, all of the valid cases that are present. So if there had been any missing values, like let's say down here this had been, let's say this had been a 2 right here, then the percentage valid would only be reflecting, these right here, these cases right here that have actual values. Whereas if you're looking in the total columns right here, the percentage total, cumulative percentage totals, then this would be a percentage out of all of the cases, even those that would include missing values. So because there aren't any missing values, these are exactly the same. The values are exactly the same in the different columns. Okay, so that's just a couple. Those are just a couple of functions within the summary tools package. I'm going to show you also how to generate a normal QQ plot using the QQ norm function and QQ line function as well. So we're going to type in first. We'll type in QQ norm and then quiz score and hit enter. And so, just keep in mind, this is not a function that's associated with the summary tools package. This is just a general function. So we just generated the plot, and then if we use the QQ line and then quiz score, you'll notice that it forms a regression line. So basically, this is utilized if we are wanting to kind of evaluate our data and make judgments about, how consistent it is with normality. And the basic idea is that the closer the data fall relative to this line, the better. That would signal that you have greater evidence for normally distributed data. And so you can see right here that maybe there's some questions about how normal the data appear. But nevertheless, that's basically how you would go about the process of looking at a normal QQ plot. We can also generate a box plot. So if we want to just use the boxplot function, this is what it looks like, and so there you go. And so there's our center, essentially the middle 50%, and then the whiskers are kind of reflecting the remaining 25% in either direction. So that's the box plot option. If you wanted to carry out a significance test to test for normality, one test is the Shapiro test. So we can just type in Shapiro.test and then the name of the data object. So we'll just type in Shapiro period test, then quiz score. And there you go. So you now have the Shapiro-Wilk normality test, and you can see we have the p-value right here. And basically the way this is interpreted is that if the p-value is indicating statistical significance, and you would interpret that to mean that your data is departing significantly from normality. If it's not significant, then you would interpret it to mean that your data is not departing significantly from normality.